Okay, so on your screen, we see a three variable K map. That is Karnaugh map, and we are going to understand how it is to be understood. So there are three variables, namely A, B, and C. There are two rows where you have a normal form of A, that is logic 1, and its complementary form A bar, that represents 0. Now, there are four columns: 1, 2, 3, 4. And here you have in each column the variable B and C that would be having the combination such as 00, 01, 11, and 10. So this is how the graphical representation should look like. When you say BC00, it means B bar, C bar. 01 means B bar, C. BC is nothing but 1, 1. And 10 means B, C bar. So when there is a logic 1, you have a variable in its normal or uncomplimentary form. When you have logic 0, you have that variable in its complementary form. Now look at the arrangement here. In each cell, there are 8 cells. That is how you write it: 0, 1, 2, and 3. Then 4, 5, 6, and 7. This is how you actually would write it. For example, in the truth table of three variables in digital logic or a Boolean expression, you have 0. That means it represents 0, 0, 0 of three combinations. Let me write here. You would see you have A, you have B, and you have C. So it would be 0, 0, 0. There are three variables, therefore, total input combinations would be 2 to the power 3, that is 8. 8 input possible combinations are there. So that's why for the first cell, you see here, when you say a decimal 0, it means it is showing you the first combination of three inputs A, B, C, that is 0, 0, 0. When you talk about in the second cell, that is decimal 1, so here you see 0, 0, 1. So here you can write in the truth table form 0, 0, 1. Then you can have 0, 1, 0. So how you see this 0, 1, 0 in the cell, you can see that this is decimal number 2. So that is 0, 1, 0. So you can actually see that I am writing here for the decimal case. This is, let's say, 0, 1, 2. Then you have 3, 4, 5, 6, and 7. Total 8 combinations. So now it's our time to see what is the logic combination of ABC for the number 3. So where is the cell where number 3 is present? So it is right over here. For 3, you can see that the combination should be 0, 1, 1. And that is how I can write here 0. Let me write here. It would be 0, 1, 1. Then number 4, you can see that number 4, we have to check where is number 4. Here it is, number 4. It would be 1, 0, 0. For number 5, it would be 1, 0, 1. For number 6, it would be 1, 1, 0. And for 7, you have 1, 1, 1. So let us write here one by one. So number 4 would be 1, 0, 0, then 1, 0, 1, then 1, 1, 0, and then finally 1, 1, 1. So this is how the truth table representation get converted into three variable K-map or vice versa. Okay, so now in each cell, after you define the numbers, that is 0, 1, 2, 3, 4, 5, 6, 7, it is easier to write the sum of product forms or min terms that is inside the cell. So for example, for 0, 0, 0 combination, whether you refer to the truth table or the graphical K-map, so for the first cell, you have 0, 0, 0. So it means all variables are in its complementary form. That is A bar, B bar, C bar. When you talk about second condition, that is 0, 0, 1, it means A and B are in its complementary form. That is why here you write A bar, B bar, and then C. C is nothing but uncomplementary form. Then number 2, you have 0, 1, 0. It means A is in its complementary form and B is its normal form and C is in its complementary form. That's why here the mean term is nothing but A bar, B, C bar. Let's have number 4. It would be A, because you see that we are in the second row where A is in normal form. However, for number 4, B and C are basically in its complementary form. So therefore, we'll write A normal, but B bar and C bar. Here similarly for 5, A is 1 and B is 0, C is 1. Look at here. Therefore, we'll write A, B bar, C. For number 6, you can always also refer to the truth table. Similarly, for number 6, you have combination 1, 1, 0. So it means A is 1, B is 1, C is 0. That's why you have C bar here. It's nothing but again you see from A is 1 and B is 1 and C is 0. That's why A, B, C bar. For the final term, that is 7. Look at the truth table. 1, 1, 1. All variables A, B, C are normal form. That's why you can write here A, B, C. So you from the truth table also, A has a value of 1, B has a value of 1, C has a value of 1. That is how you write here A, B, C. So this is how a graphical representation of three variable K-map. So hope you found this module useful to understand how to form a three variable K-map. If you did so, share it with others for wider reach and stay tuned for more engaging content like this. Till then, wish you a happy learning.